Now this is an example how to run a correlation between two variables, right? We want to see if, for example, the German score, how strongly associated is that with the math score? How well do these go together? So we're going to analyze, correlate, bivariate, bi meaning two variables. So we choose math, click it over, and German test has the wrong scale here, so we just use that as an example. How do we choose a scale? We change it, we go into variable view, we see German, we go all the way over here, we see the measure, what scale level is it on, it's a nominal, we click on it, we choose scale, and we save it. We go back, and we save that, and now when we go into analyze, correlate, bivariate, we should get okay, the sign here, it's a scale. Click it over, German, math, and the options we can ask for means and standard deviations, and we choose the Pearson correlation coefficient. There's two other ones when we have different scale levels. For example, ordinal scales, we can use these two, but we're just going to stick with the Pearson, and we are going to test it two-tailed. If we have an idea if it's going to be positive or negative, we're going to choose the one-tailed significance level. Okay, and we get the display. German test, average 36, standard deviation 6.85, 100 people. Also for math, we have 100 people, 31 mean, 6.5 standard deviation. And now if you look at the correlation down here, so the German test, the first number is correlation with itself, is 1, right? It's logical, it's the same, always the same thing. And then the correlation with the math is 0.580. Then we see here the significance level, the two-tailed is right below, and the n, the sample size that this correlation coefficient is based on. So based on these 100 people, the math and the German tests correlate by 0.58, and it's highly significant. It's way above, way below the 0.05 significance level. We reject the null hypothesis that there's no correlation. We go with the alternative hypothesis there is a correlation. And how strong this correlation is, you have rules of thumb in your book on page 120. You could say that this what kind of strength this correlation has. Then what we can also do is, if we enter multiple variables, for example, I'm going to add the rest in here. And these are at different scale levels, but we can still, we don't have to be at the same scale level because the correlation is a standardized coefficient, right? We can compare, for example, German test, which is from 1 to 50, with hope, which is from 1 to 4, or self-efficacy, which is from 1 to 4, or cognitive ability test, which is from 1 to around 40, I believe. But these we can compare with each other's correlation coefficients. So we see they're all highly significant, and we see German correlates the highest with math, then German correlates a little bit lower with hope, 42, then 46 with self-efficacy, and about 46 with cognitive ability test. So we could say German correlates about as strongly with self-efficacy as with the cognitive ability test. Then you could also do then significant tests about the difference between correlations. Well, is this correlating higher, lower with math than self-efficacy, or is math higher correlated, so statistically significantly higher correlated with German than hope? But this is another story, but here just to show that you can make these tables.